his thesis. Monter is a Plan A student, so he is doing the thesis route, and he's been working as a research assistant for the past 2 years, working on the smart antenna system that we've been developing here at MSU. So, Monter, move for it.
Okay, so the project is just me. However, like the surprise, my name is actually pronounced Monter. Well, but Monter is okay because I know it's like the Monter. It's kind of like real heavy on that tongue, so everybody's excused. And today, I haven't really said that to Brock before, actually. because
So have I.
I tried it with other people. Yeah, even my host mom.
And today is the worst day to remind them.
You should have waited.
Well, you know, had to come out sometime. So, anyway, so I'll present my project today, which is Monter. But people, my mom sometimes call me Monzer with a Z. So yeah, but Monter is like really hard. I mean, it's not. Yeah.
Our lips just don't.
So Monter is
My
fine.
tongue doesn't
Monter,
grab
all
that
the
way.
variations. As long as
What's the Y now?
What's the Y? Well, that's my middle name, and it's my father's name. That's how it is. So we use like the father in the middle name, and then like sometimes we go even longer. So I have the names of like my great grandfathers. But anyway, so anyway, so I'll present the digital implementation of direction of arrival estimation for smart antenna systems. Been working on this project for 2 years, and here you go for presenting what I did and the results. So I'm going to go over an overview of the overall system and the smart antenna systems in general, and then my system overview, and then talk about Bartlett DOA. DOA stands for direction of arrival estimation, and I'm going to talk about custom HDL, hardware description language, implementation, and soft processor-based implementation, hybrid implementation, and then comparison analysis. Then move to NVIDIA DOA estimation, talk about the hybrid implementation, talk about results analysis, and do a little bit of speculation of hardware performance, then talk about future work and conclusions.
So what does NVIDIA stand for?
NVDR stands for minimum variance distortionless response. So sorry. Well, anyway, the term is too vague. Anyway, smart antennas, they are systems used to do directional patterns for receiving and transmitting. So instead of transmitting the signal to everybody all over the space, the signal is only transmitted to the user we're interested in communicating with. It allows us to nullify interferences, also to take data from unwanted listeners by just directing our information towards the users we want to communicate with, and reduce the transmit power by only focusing on the users we're communicating with, which allow also for extended range, as you see in the pictures in here. So the research group at MSU has been building a smart antenna system. This work has been sponsored by AEC, and I think there's a grant from the government from Montana. And the first phase was to design a PC-based system which performs directional arrival estimation and beamforming. The PC-based platform or system uses the anechoic chamber and the circular antenna to receive signal and send it to the computer for post-processing, and then determine the directions of arrivals and pick a pattern, a radiating pattern, in order to communicate with the users, which is sent again to the antennas. So the second phase is to move the DOA estimation algorithms from the PC into a portable digital device. for portability and other reasons. So my research focus was to implement the DOA estimation on that digital hardware. In the work, implemented two directional arrival estimation algorithms, Bartlett and MVDR. Well, I looked at the performance impact of these different implementations of the custom HCL, soft processor-based, and the hybrid implementations. I used this ML507 board for my testing platform. So, why digital? The main advantages of a digital system over an analog system, no hard feelings at Andy, so.
No, I've been pushing for it for years.
So,
Tis the future.
yeah. So it reduces complexity, easier to design, simple data storage, since we have binary data that all care about, high performance and more flexibility, and also there is a property we can do real-time reconfigurations. It's less expensive and more immune to noise. So the digital DOA system can be implemented using a lot of algorithms. We picked, using different technologies. So such as like FPGAs, also soft processors, microprocessors, as well as, for example, you can use an ASIC device or something to run the system. The main factors to be considered are performance, which is how fast the system can operate and detect or estimate the DOA, resource utilization, and implementation time. How long would it take to implement the system? So here at MSU, they designed a system consisting of 8-element circular antenna array connected to a receiver board. This is one-way connection. This receiver board is down converts the signal, the RF signal, radio frequency signals at 5.8 gigahertz, down to whichever intermediate frequency is used. I think they used 1 megahertz, or it's also now 10 megahertz. And then it's digitized through a DAC card, data acquisition card, and then sent to the PC in order to process the information, detect the directional arrival signals, recognize users, all these functionalities. And then the PC would configure the RF beamformer in order to form either to nullify interferers or form beams toward the users we want to communicate with. And then with the radio, altogether they form the signals to be sent to the circular antenna array in order to form the radiation pattern we're interested in. So the contribution of this project provides an optimal system that partitions the algorithms effectively to balance between development time, resources, and critical path performance. Also, it provided a complete prototype for testing a system on hardware, and it's a fully digital system prototype in a single chip solution. It's all implemented in the FPGA. So as you see here, we moved the stuff, or the algorithms, from the PC to an FPGA and used an ADD board rather than a DAC card. So novelty of this project, as I mentioned, it's a full DOA system implementation, and also it provides hardware versus software implementation comparisons. We looked at both the hardware or custom HCL implementation and how the system will perform in a microprocessor. Also, it's a full single chip digital solution, which means we use only one chip, FPGA, to perform all the algorithms. So, an overview over the system. In order to do functional verification and testing, we used a setup that consists of 4 signal generators controlled by LabVIEW. This setup was designed, I think, 2 years ago by Ray. I don't know if he's here. No. Oh.